All right, welcome everyone to turning Microsoft login page into our phishing infrastructure. And most importantly, welcome to our special guests from Microsoft, right? Welcome people from Microsoft because you guys really have to be my biggest fans. See, when my talk title and description got published by DEF CON, I fairly quickly received an email from Microsoft's Security Response Center asking me for a preview of my slides. However, the thing is, before I actually published this presentation to DEF CON, I already made the decision that I would not be sharing anything with Microsoft. And you'll be thinking, okay, but what about responsible disclosure then? And I agree, actually, but the thing is, if I would have reported this to Microsoft without this talk being a thing, I know for certain that they would just have returned their provide me their classic response saying this is not a vulnerability, it does not meet the bar to meet to do immediate servicing, right? So to save some time for the both of us, I responded to them and said, look, everything I will be sharing in my talk will not meet any bar for immediate servicing, so let's save some time for both of us, and you don't need to worry about it. But they weren't really happy with that. They still encouraged me to submit my findings to the MSRC for review, even if they don't meet servicing requirements and bounty eligibility, right? And when that didn't work, they were very persistent. They sent me an invitation for a conversation with some free food and drinks, hoping that maybe that would get me to share my talk. But once again, I said, okay, thank you for the invitation. I have something else to do. So, and I thought that would have been the end of that, but they were actually really, really persistent. They upped their level a little bit, and they invited me to the MSRC party at the Skyfall Panoramic Bar, which has this amazing view over Las Vegas with some great food, some swag as well. So, yeah, this was a little bit too nice to turn down, so I went there, freeloading a little bit, without sharing them any of my talk. So, I am very happy that I will now be able to share my slides with Microsoft and with the rest of DEF CON also watching, but I suppose you guys will do nothing malicious with that, right? So, before we start, let's do a quick introduction about myself. I am Keanu, also known as RedByte online. I lead a small offensive security team at a Belgian company called Spotted. I'm also the author of GrabSpy, an offensive security toolkit used for initial access and post-compromise enumeration of Entra ID and Microsoft 365 applications. And I'm also the instructor for several Azure Red Teaming trainings at Alto Security. But enough about me, let's actually get into the fun stuff because I have a lot of new techniques I want to share with you guys. Right. I'll go over a quick introduction. I'll keep this very brief because I want to use the majority of my time to actually go over the new techniques I want to share with you guys. So, if you have done any type of assessment requiring you to send out realistic phishing emails without any whitelisting in place, you will probably relate to some of these challenges that you could encounter. Right? You have email security solutions that could block your suspicious links in there. There is user awareness where they focus quite a lot on hovering over the link and seeing if the domain name is legitimate, right? Nothing we can't really get past to with a good pretext, of course, but still something we need to take into consideration. It takes quite a lot of time to get a benign domain categorization, of course, and constantly recycling your domains when they are burned can be a little bit tedious, right? So what alternatives do we actually have for that? Right, so we have, if we don't want to use a malicious domain name, we can, for example, use consent grant attacks, where we will be using the legitimate Microsoft domain and be phishing a user for consent to their permissions over their emails, their files, whatever we want, without phishing their password, right? However, most of the interesting permissions require admin approval, especially in hardened tenants. You would see that admin approval would be required for everything. There's also verified publish restrictions, which is not that big deal to get around to, but still it's there. Device code phishing is still very useful. We still use this very effectively quite a lot during our assessments, but it could be blocked in hardened tenants as well. Right. with conditional access policies. And then adversary in the middle is obviously very useful to make your website look very convincing. You're basically interacting with the real website, but on a malicious domain name. So that's also a drawback on that. You're basically in the same situation as previously. If your domain gets burned, you will need to rotate that and so forth. Right? So I was interested in this instead. Can we use the trusted login.microsoftonline.com, so the login domain used for all kinds of authentication purposes by Microsoft? Can we use this domain for phishing purposes? And I was looking into this, and I found that this was actually a little bit too easy, so I quickly changed that into in how many ways can we abuse this Microsoft login page for phishing purposes. Right? And I will show you a couple of them, starting with some basic examples where you will still have some ways to actually see that something fishy is going on if you are a little bit tech savvy. At the end, we will be showing some very advanced techniques that completely destroy the login page. We will be extracting clear text credentials and bypassing multi-factor authentication, all while staying on this legitimate login domain. Right. So without losing too much time, let's get into that. Before we do that, let me give you some honorable mentions of things that I also found, but I didn't really have too much time to talk about that. In general, these are some open redirects. I will share a couple of them. These are still working as all of the other things that are still working. Right. First, you can use federation as an open redirect. So what you can do is you can configure a domain in your attacker tenant. Set the sign-in URL for federation to your phishing page, and then you can craft a URL that looks something like this, login.microsoftonline.com, and then with some parameters with the login hint of the domain that you set up for federation. And if you would forward that link to the to your victim, it would instantly redirect to that phishing domain where you can host something like EvilGenX or whatever you want to capture credentials, right? So basic open redirect, which is basically known of how federation works. So this is probably something that they can't really patch. Additionally, another thing that you can do is you can create an app registration in your Entra ID tenant with a redirect URL to your phishing page, and then create a URL with the prompt equals none parameter, and that would basically bypass the consent prompt being shown or any type of prompt being shown, so no login page or whatever, and it would instantly redirect to your redirect URL, right? Even if with the most restrictive consent settings, it would still instantly redirect. And then a slight alternative to that, what you can do is create, once again, an app registration with your redirect URL to your phishing page. However, here we will craft a URL with an invalid scope parameter. And what happens over here is the user will be redirected, but only after legitimate authentication. So they will still see a little bit of the login page. They will stay there, sign in with their legitimate credentials, MFA, whatever they would need. And after they sign in, usually the consent prompt would be shown. However, because we are using an invalid scope that Microsoft doesn't understand, it will throw an error. It will not show an error, but it will instantly redirect to the redirect URL, right? Even with the most restrictive user consent setting. So a couple of open redirects, which I shared with, these three I shared with Microsoft to give them something. I have not received a response about that, but I'm fairly certain that this is something they can't fix. I will show you a quick demo of the last one. Right. So at the left you have the attacker point of view. At the right you have the user point of view. So this is the URL we would send to the user, for example, that we want to phish. So it's an invalid scope. That's the most important one. So we copy that one, paste that into the browser. All right, and you would see the other ones would instantly redirect to your phishing page. This one will stay on the legitimate Microsoft login website for a bit. It would ask you to enter your password, whatever, do multi-factor authentication if that is required. And as soon as that happens, you would see it would redirect to our malicious website, where we can, for example, say, okay, because you're accessing sensitive information, you are required to sign in once again, or you can say your password expired or whatever. But something like this would be very useful for certain pretext, right? All right, and at the left you can see we have EvilGenX running, which is capturing the credentials bypassing multi-factor authentication and extracting the session cookies of the user. Right, so this is how that would look like. All right. So open redirects are nice, but I didn't want to talk too much about that because, to be honest, they are not that impressive, of course. Can be useful in certain use cases if you want to use that, right? But let's look at some other approaches. And for the first one, I will be talking about, or I will be using self-service signup. So what is self-service signup? So self-service signup basically allows external users to sign in for to applications in your tenant with their own credentials. So they will basically, when you set that up, be allowed to register a guest account in your Entra ID tenant without being invited already or anything. Right? This can be useful in certain use cases. Obviously, by default, that is disabled, but you can enable that if you want that in your Entra ID tenants. And the interesting thing about this is that you can collect custom attributes during the sign-up flow, right? And you can collect certain types of default attributes, such as the job title, display name, anything you want. However, nothing stops you of creating a custom attribute called password, for example, and an additional integer, for example, called MFA code, right? So these attributes would be collected by Microsoft during the sign-in page, and the user would be requested to fill in whatever they want for these values, right? So, and then you're probably thinking, okay, but how do we validate whether the password is actually correct or not, right? Because the user can fill in anything over there. So with an API connector, we can actually do that. What the API connector will allow us to do is it will allow us to do input validation of all of the inputs that is provided in these custom attributes, right? So with this, we will be able to validate the password, return an error message if it's incorrect, right? So let's look at how the attack would work. We send a link to the user. They would click on that. They would go to the login.microsoftonline.com domain, obviously, as all of the examples that I will be showing. And after that, they will need to sign in with their account of their home tenant, right? They will need to accept the tenant invite. And after that, they will be asked to fill in the attributes that we want. So the password and whatever, right? They will fill that in on Entra ID, which will forward that to our API connector. The user does not directly interact with our domain, right? So everything goes through Entra ID. So the attributes are collected, they are forwarded in clear text to us, right? And at that point in time, we can actually validate that against Entra ID if it's correct or not. If it's incorrect, we can tell the user that they need to use a different password. Otherwise, we have the credentials of the user and we compromise their account, right? We basically continue this until they provide valid credentials. Right, so this is what the URL would actually look like. So login.microsoftonline.com, client ID of the application that we set up in our attacker tenants for self-service signup, and then a login hint of this is our victim user, right? So an email address of the victim user that would allow it to be pre-populated on the sign-in page, so an additional step that the user does not need to do themselves. And we use prompt create to force the registration page to show up. Otherwise, they would need to click on something. So the more things we can automate for the user, the better, right? So prompt create plus the login hint will force the sign-in page with the pre-filled email address to be showing up. The user signs in with their credentials, accept the tenant invite. This is not a consent prompt, so even if the most restrictive consent settings are configured, it would not really help there. And at that point in time, the custom attribute collection page would be shown where we capture the credentials and validate that with our API connector, right? So let's look at that with a demo. So you know how it looks like. At the left, you have the attacker point of view. At the right, we have the victim user point of view. So we paste that URL that I shared previously. This is what they would end up on. So they sign in with their valid credentials. They accept the tenant invite. And then this is what the attribute collection flow would be looking like. But the interesting thing is this is all on the legitimate login.microsoft online domain, right? So it has some trustworthiness to it. You can see over here if we enter a incorrect password, we can return custom error messages saying that the password is incorrect because we can validate that. So provide a correct password with invalid MFA code, we can return a different error message. And if the user provides a correct MFA code and a correct password, you will see that we can return a custom error message, right? So we can also redirect to users anywhere we want at this point in time if we wanted to. But we have everything we need right now. We have access tokens, refresh tokens, session cookies. The complete account of the user is now compromised. All right. If you find that impressive already, wait for the next ones. So I have some backup slides. So the next one, I will be looking at abusing custom company branding, right? So custom company branding, this basically allows us to customize the look and feel of the Microsoft Entra ID sign-in page, right? So what could go wrong? Quite a lot, we'll see. This is from the documentation from Microsoft, all of the things that, or a couple of the things that we would be able to customize. This is used quite a lot by organizations, mostly to load a custom background for their sign-in page, for their organization. However, I've noticed that you can actually customize quite a lot more than what their documentation describes. Right. And one of the interesting things that you can do with custom company branding is inserting a custom CSS file, right? You cannot customize, luckily, any HTML or JavaScript, right? That would be really bad. However, you can customize a little bit what the page of what it would look like with CSS, right? However, not all CSS is obviously allowed because the nasty CSS is filtered out. I was looking into, okay, how does it define what is allowed and what isn't? And basically what happens is, when I was looking into that, it will always, if you load the login page, it will always return the completely unfiltered CSS file to the browser. And then it will filter the CSS with client-side JavaScript. That basically means that we can actually see in the source code everything that it is filtering for, right? So for future reference, if you wanted to know, these are all the properties, CSS add rules, functions, whatever that you are allowed to or not allowed to utilize. So this was very useful to look into what we could do. So I was playing with this, looking with this, okay, what can I do with that? I found that you could target the sign-in buttons, for example. So what did we do? I first hide the sign-in buttons, and they are gone right now. So you're thinking, okay, what can we do with that? Well, if we look at some of the other options in the custom company branding, we are basically also allowed to customize the self-service password reset, right? And what this would allow us to do is we can basically show a custom link that would be redirecting to our whatever domain that we want with any value that we want. So we can do something like this. The next button that we previously just hit, we can replace that with something like that. Obviously, right now, no one would click on that. No one would be too stupid to click on that. However, if we customize that a little bit more with a little bit CSS, right, we can make that link look something like that, right? So now it looks quite a little like this next button, right? And even if you hover over it, it has some animation that it changes the background a little bit. But you say, okay, now it looks great, but it's at the wrong location, right? And you're correct, but we can move that a little bit with some relative positioning. And now it's exactly to the pixel correct where the real next button would be, right? So we can do this for the next button on the account fill-in page or on the next page to collect the password as well. We can basically hijack these buttons, right? So how would we abuse this, or what URL would we be using for that? Once again, login.microsoftonline.com, and we will just add our tenant ID in there, and that is basically enough to load our custom CSS from our tenant, right? And these tenant IDs, these are GUID, so users would never actually know whether that's someone else's tenant. Maybe if you're really tech savvy, but no one is going to be looking at that, right? And then what else do we have? Prompt login. This is basically to force the Microsoft to show the sign-on page, even if you're already signed in with some cookies in your browser. Right? So prompt login forces to show the sign-in page. User enters their email address on the domain, clicks on the next button, and then they are redirected to a malicious domain where we can capture their credentials, for example, with adversary in the middle. Right? All right, so what does that look like for the user? So they are on login.microsoftonline.com. For example, we are phishing the CEO of Microsoft. They provide their email address. They click on the next button and they see the password fill-in page, right? But this is on a different domain, but it's so seamless. The user doesn't see it. They click on the button and they see the next page that they're expecting, but on a different domain, right? So it's very, very powerful. So let's look at an example of that. So we go to that domain. User fills in their email address, clicks, you can see if we hover over the button, there is this nice animation. We click on that. At the left, you can see either GNX loading already, loading the login page. We will pre-fill the email address of the user. We can load custom tenant branding of the user, whatever we want. User enters their password. And if they sign in, they would get an MFA prompt or whatever. Obviously, we don't know the password of the CEO of Microsoft, of course, but you can see where this is going, right? This is just for a demonstration. All right. Let's look at something else we can do with pass-through authentication. So pass-through authentication is one of the methods that you can use to allow your users to sign in with their on-premise credentials to any Entra ID integrated application, right? So the way that this works in the background is Entra ID will literally forward the password in clear text to your on-prem agents, where on-prem PTA agents, which will decrypt the credentials and validate them against a domain controller, right? So this is fairly abused quite a lot already. It's a well-known post-compromise persistence attack technique where you backdoor the PTA agent and you basically wait for authentication attempts and you extract clear text credentials from that, right? So this is usually done after full domain compromise. You compromise someone's on-prem environment and then you install this backdoor, right? Which requires quite a lot of high privileges. So how does the authentication flow work? So the user goes through any application, it will be redirected to Entra ID, right? Entra ID will ask for the credentials. So the credentials are added on Entra ID's login page, which will then be forwarded to your on-prem pass-through authentication agent for validation. At this point in time, your passwords are in clear text on this agent, and they will validate that against the on-premise domain controller. And what is also important to know, the pass-through authentication agent here is in charge of whether they want to accept or decline the authentication or not, right? So that is how it works. So as I said, it's a known technique to use this for persistent purposes. However, what my idea was, can we use that for initial access? Can we use pass-through authentication, set that up in our attacker tenant, right? And steal clear text credentials of users in other tenants, right? So this was my plan. I set up pass-through authentication in our tenant that I control, so I can do that. I backdoor the PTA agents on premise, which is running on a server that I control, so I can do that as well. So this is all fairly straightforward. But then the tricky part becomes we need to trick users from other tenants to sign into our domain or to our Entra ID tenant, right? Otherwise, we wouldn't be able to get their credentials. So this one is easier said than done, but let's look at that in a little bit. So let's first look at the first step. I will go over this briefly. It's very boring, but it's all documents from Microsoft, how we can set that up. So we set up an Entra ID domain. We set up Entra Connect Sync. We set up pass-through authentication over there, go through all the steps that are needed, and eventually we see pass-through authentication is enabled for our tenant. Right. Then second thing we need to do is we need to backdoor that pass-through authentication agent. Right. Here we will be using PTA Spy from AAD internals by Dr. Azure AD, but there are a lot of tools that do the same thing basically. But PTA Spy is very easy to install. We just use install AAD int PTA Spy on our PTA agents. And then after that, when we test that by signing into some accounts from our tenants, we will be able to see the clear text credentials, right? So now let's look at the other part. How can we force users from other tenants to sign into our tenant? Right. There are a couple of constraints to that of what we are restricted to make it still collect the credentials with PTA. Right. So we can only target users in our own tenant. Otherwise, they wouldn't be able to sign into our tenant, and then definitely it would not be able to use PTA from our tenant. Right. Pass-through authentication also only works with hybrid users, so cloud-only users will not work. For example, guest accounts are cloud-only users, so these can't be synced to on-prem, so something like that would not be possible, right? So what other options do we have? I was looking into this setting, email as alternate login ID, because it is very underestimated feature that can be fairly useful in some cases. Basically, what this allows you to do, if you enable that in your tenant, you can basically allow users in your tenant to sign in with any email address that is defined in their proxy address attribute. And this proxy address attribute can, in certain cases, have email addresses from unverified domains, right, that you do not own. Right? So I was looking into that for a cloud-only user just to test this really quickly. If you said you cannot control the proxy address directly, but you can, for example, update the email attribute, and for cloud-only users, this gets propagated automatically to the proxy address field. So you can see over here, we set that to nonsynced@microsoft.com. We don't own the Microsoft.com domain, but we can still do that. And after that, with the previous setting, we can actually sign in with that account into our tenant, and it will be linked to that specific user, right? So this, you could think that probably is something you can actually trick a user of a different tenant into signing in with our tenant, right? Because their email address could be displayed on our login page, right? However, when I looked into that for synced users, then we saw that this email property is not propagated. And I tried a lot of things to try to influence that, but even setting the proxy address fields on-prem, for example, it does not automatically propagate to the proxy address field in Entra ID. So there was no way for synced users to influence that to get unverified domain names in there. And this is documented by Microsoft as well. Right? So I needed to find something else. And that's why when I started looking into the custom CSS that I showed previously. Right. So I was thinking, okay, can we maybe modify how the email property is shown on the login page with custom CSS? And I was looking at all the attributes that we can customize, or the custom selectors that we have in CSS, but none of them allowed us to directly select the email address that is shown on the page. However, the closest one that we do have is something like the sign-in box, or we can set CSS to the complete body. That is still possible, but things like end child or anything similar that would allow us to only select that email address are all disallowed. So we can't do that. So what we would need to find is some way to set something on a parent element on the page that would only affect the email address property without modifying the rest of the page. So I was looking in the other things that are allowed, and then I saw font face. And font face allows you to basically select or define a custom font that would be used for your page. And we can apply that to the complete body or to the sign-in container, doesn't really matter. And then I was actually defining looking into, okay, how can I create a custom font? So I found this neat application that would allow me to do that. And as you can see over here, this looks quite a lot like an S. However, if you look at a little bit closer, this is actually a hyphen, right? As a human, you would think that this is an S, but the computer will think that this is a hyphen. This is a dash character, basically, right? Really swirly dash character, but it's a dash character. So what we can do is now purchase a domain, micro-off.com, and the computer, your browser, will think that micro-off.com will be there, but it will render it as Microsoft.com, right? So now we can, since we verified that domain, we own that domain, we can create any users with that email address, like admin@micro-off.com, for example. We can set up some conditional access policies if we don't want the user to gain access to our tenant after we phish them, for example. And then we set up this custom CSS to implement our custom font, right? We load our custom font from a specific location, doesn't really matter. And we set that font to only take place on when the hyphen character is loaded, right? So only use that font for the hyphen character, which is 2D in hexadecimal, right? And then all the other fonts are basically the normal fonts that Microsoft would otherwise use, right? And this is what it would look like for the user. So the user sees admin@microsoft.com, but if you look at the source code, it is admin@micro-off.com, right? So very convenient. And our phishing URL can be as short as this, login.microsoftonline.com, and then a login hint with our email address of the user we want to phish, with a slight modification at that. Obviously, the user might see that, so you can do a little bit obfuscation or encoding of that. You can use some URL encoding over there. You can encode whatever you want, a small part. The complete email address, you can add any parameters in there to make the URL look more legitimate, right? At the end, it will be very hard for the user to see that this small modification is in there, right? So let's look at a demonstration of that. So this is our attacker server where our PTA agent is running and PTA spy is running. So right now you can see it is installed, but there are no credentials just yet. So this is the victim point of view. they go to our phishing domain, or they go to login.microsoftonline.com, you will see it looks like admin.microsoft.com, and you can also see it will show up the credentials from their password manager as well, because they are on the legitimate Microsoft domain. After they sign in, we get their credentials in clear text, basically. Right. All right. Thank you. But there are still a little bit of limitations to that, right? If you look at the previous demo, you might have seen that. Obviously, a wrong password can be provided by the user because PTA spy will always return a successful authentication without validating the password, right? So we need to take care of that. And the second thing is clear text passwords are nice, but they are useless if multi-factor authentication is enforced, right? So let's see what we can do to work with that, right? So we will use the same CSS as previously, but we will add a little bit of extra CSS to that, basically to modify the title that will be shown on the sign-in page. And what is a title? This is basically the area between the email address and the password field, right? So we will hide that title, and we will actually load a custom image from a location that we control from our attacker web server, right? So what will we be doing with that? The first time that it loads, we will, and it requests that image, we will return this image. Enter password, so just regularly as usual, this would be what would be shown the first time. After we have validated the password of the user, we will redirect them to the login page a second time, and then we will load this image. Enter code. And now the login page would look like this, right? And since we are using password authentication, we will be actually be capturing that OTP code once again with our backdoor of our password authentication agent, right? Then we also need to modify how the PTA spy works a little bit, because as we said, it will always return a valid authentication attempt. It will not validate the credentials of the user. So how PTA spy works is basically on the PTA agent, it will hook the login user API call from the Microsoft API, the Windows API, right? What we will do is we will modify that hook a little bit, and we will actually implement a new function that will validate the credentials. It's too big to actually show here. I might share that on GitHub in a while, but for now, I will just show you a little bit of snippets from this. And if the authentication is successful, we will return successful authentication. Otherwise, we will return an error, and Microsoft will show that error, and the user will enter a new password, right? So how will this go in the background? We send a link to the user to our sign-in page of Entra ID. Right? They will click on that, and obviously when the sign-in page loads, it will request that image. So the first time it loads that image from our web server, we return this image. The user will enter their password because it is instructed to do that, which will be forwarded to Entra ID, and Entra ID will forward that to our password authentication agent. Right? At this point, we validate that password against Entra ID. Right? And if the authentication is successful, we return that. If it's unsuccessful, we return an error message and they can try again. Right? Let's assume it is successful. What we will do is we'll let our web server that's hosting our image know that the authentication was successful. So it knows next time if we need to load an image in the next couple of minutes, we know that it needs to return the other image. Right? At this point in time, we also redirect the user to the login page once again. And they will receive the image once again to be requesting their OTP code, right? They will provide the OTP code in the password field, right? Which will be forwarded to our PTA agent. We can validate that once again to Entra ID. If it's unsuccessful, we can return an error once again. If it's successful, we compromise the user account. So this is the ID behind it. What would our sign-in URL look like? It's a little bit bigger, as you can see over here. So once again, login.microsoftonline.com, and a client ID of our application that we have set up with a custom redirect URL. The prompt login to force the login page to be shown even as the user is already signed in, which is required because we will need to sign in the user 2 times, right? And then the email address of the user we want to target. And then the redirect URL will redirect the user after successful authentication once again to the login page. And you can see it's a little bit nested over there. But then the third time or the second time they successfully sign in, they will be redirected to wherever you want to go, Google in this specific case. One small note for the demo is that usually we would rewrite something like micro-auth.com authentication attempts. For that, we would rewrite that to Microsoft.com and validate if the credentials are valid for that account, right? Obviously, since I don't have access to a @Microsoft.com domain, and I asked them, but they said no. I even told them, you can see my slides if you give me the account for the demo, and they said no. So, so because we do not have access to that @Microsoft.com domain, what I will be doing is I will show the demo where we capture the credentials for the user for @Microsoft.com, but instead of validating the credentials against a Microsoft account, we will validate them against an account that I have control over, that I know the password of, so I can phish myself, basically. Right. So let's look into that. So over here, we have the victim point of view in the bottom left corner. Everything will happen on the legitimate Microsoft login page, so they will be asked to enter their password. If they enter an invalid password, they will receive an error message just to show that we are actually checking for that. We still have the password, of course, but we know that it's invalid. Right? If the user provides the correct password, for example, the one that's saved in their password manager, then it will seamlessly load the enter code image. Right? And if they provide the correct MFA code over there, we can redirect them wherever we want, and we basically compromise the user. Once again, we have their access tokens, session cookies, anything we need. All right. So this is nice once again, but there's still a couple of limitations to that. First, we are capturing a MFA code in a password field, which is a little bit suspicious because usually the OTP code is in clear text, right? Additionally, authenticator app notifications are a little bit more convenient in company environments, right? They are used quite a lot more and they are more convenient for the user. So I was looking in, okay, can we actually do something with that instead, right? And for that, we will actually need two Entra ID tenants. The first one will have the same CSS as we saw previously. It will only replace the hyphen with an S character, right? The other CSS that you saw previously, we don't use that. And yeah, it's basically the main sign-in page that you saw previously, right? Then the second tenant, which we will redirect the user to after authentication, will have this CSS. And basically what this will be doing is it will replace the complete sign-in box with an image. And you're thinking, okay, what's the image? An image looking something like this. Right, showing the two-digit code that would be that they would need to sign in on their authenticator app. Right? And you're thinking, okay, but how do we know in advance which specific two-digit code that the user needs to enter? Well, we don't know, so we just generate an image for all of them. Right? So this took quite a while. So I have 100 images ready over here, and basically it doesn't matter what image that or which code that Microsoft provides us, we can return that. And this is how the attack flow would go. So we send a link to the user to sign into the first tenant, right? Which will, there's not much modifications on that one, just replacing the hyphen with an S character in this specific case. So the user would provide their credentials, which we will capture on our PTA server. We can validate them. If there is an error, we can return that. If not, we return a successful authentication. And at this point in time, we will also receive a two-digit MFA code from Entra ID, if MFA is set up, and we forward that to our web server, right? So, for example, 42. We redirect the user to now tenant 2, where our different CSS is loaded. And there it will actually load the image, right? Because we're replacing the complete sign-in prompt with an image and whatever code that is needed, right? In the meantime, our attacker server is constantly polling, checking if the authentication already succeeded with MFA, right? The user will see the two-digit code. They will also look down because they just received a notification on their phone to ask for the two-digit code. So they provide that, which will be forwarded to Entra ID. And at that point in time, we compromise the user's account. Right. So let's look at our final demo over here. Once again, login.microsoftonline.com with some custom properties, which you can see over there. And the redirect URL will just redirect them once again to the login page of the second tenant. So you can see that in action over here. First time we enter the password. So it's going to be an invalid password the first time. So you can see no redirection if the user enters an invalid password. If we take the correct password from our authenticator extension or whatever, right? The user will be redirected to the second tenant where this image would be shown. And as you can see over here, the user has entered their multi-factor authentication on their app. We get their access token, refresh token, and their session cookies. You will see they will not be redirected over here. So this could be something that they will note. However, they are still on a legitimate Microsoft login page, so it is not that suspicious, right? All right. So for that, we would actually need 2 tenants. You can actually do something where you only use 1 tenant if you really want that, but then you would need to use this browser language customization. And what this allows you to do is specify custom tenant branding for a specific language, right? So for each language, you could load a custom CSS file, which would allow us to, for example, do something like this. By default, in any language, it would return the normal login page. If the language is set to French, for example, we return the MFA prompt. And we can actually modify which language is used with this parameter, this LC parameter. We provide an ID over there for French, for example, and then it would load the login page, right? So this would allow you to do this exact same attack with only 1 Entra ID tenant. However, you will note one slight difference. If you change the language, it would also change the language in the page title. So this could something that could be seen, but probably not too suspicious for the user, and they will probably not notice it because they just received a notification in their Authenticator app, right? So to summarize, I showed about 8 techniques. The open redirect ones, I went over them fairly quickly. If you are interested in that, the slides for that are at the back of my presentation as well, because I first created some slides for that. So you will be able to see that still. 4 of these techniques we can actually be using or staying completely within the legitimate login.microsoftonline.com tenant domain, right, without going anywhere else. And a couple of them will also bypass multi-factor authentication, right? So to summarize, login.microsoftonline.com is a free redirector for phishing pages. It can serve any image as if it is imager, right? So if you want to host cat memes on Microsoft's login page, you can do that if you want. Right. It is the most trusted credential harvester by far, and it's basically the perfect all-in-one phishing platform, phishing as a service platform. Right. Some references over here from obviously Dr. Azure AD for his awesome work with AD internals, and PTA Spy, which we use quite a lot over here, which is based on the research of Adam Chester, actually. And also to a quick shout out to Kuba, the creator of EvilGenX, which allowed me to use the EvilGenX Pro version for some of these demos over here. If you have any questions, feel free to come ask me after the session or reach out to me on my socials. You can see that over here. And I just want to end over here with a picture that I took at the Microsoft party 2 days ago, which basically summarizes this entire talk. I'm not sure if you can see it, but they had like this small sign over there saying game over, and they allowed me to take some pictures over there. So yeah, thank you so much.